right, in this lesson, we're going to learn physical and chemical changes, physical and chemical properties, and the difference between physical and chemical changes, as well as examples. We'll start with physical properties. Physical properties can be observed or measured in a classroom or using 5 senses. Physical properties may include appearance, texture, color, odor, melting point, boiling point, density, solubility, polarity, and many others, including magnetism. Physical changes. Any change in a substance that does not change the identity of the substance or the chemical makeup will be a physical change. For example, cutting paper. After the paper is cut, it is still paper. A good rule of thumb is, if the object keeps its same name, then it is likely a physical change. However, this rule of thumb is not perfect, because there are many objects that when they change in size, we call them new names. That's not because they change, it's because of the English language. So, it's best to look at other examples, and so you could just remember what is a good example of a physical change. So common examples include ice melting. Any phase change is automatically a physical change, going from solid to liquid, liquid to gas to solid, or solid to gas. Those are all physical changes. As I mentioned earlier, cutting paper or ripping it is still a physical change because it's still made of paper. Mixing will be a physical change as long as there is no signs of a chemical change along with it. So for example, mixing iced tea in water, you just have water that has tea particles inside of it. Chewing food, but not actually eating the food, would be an example of a physical change. Now, if you're looking at a chemical formula for a physical change, when the chemical formula on the left and the right, the reactants and the products, if the object or the letters are the exact same on the left and the right, then it must be a physical change. For example, on the left, we have H2O in its solid form, and on the right, we have H2O in its liquid form. If it's the same, then nothing chemically has changed. It must be a physical change. Now, let's look at chemical changes. So a chemical change is a change in a substance that results in a new substance being formed. So for example, in the picture right here, the wood starts out as wood, but after it burns, it is no longer wood. It'd be considered smoke and ash afterwards. A good rule of thumb is, if you cannot change something back without using more chemicals, then it must be a chemical change. If you can change it back without using chemicals, then it should be a physical change. So in our previous ice example, if you took that water that the ice melted into and put it back into a freezer, it'll turn back into ice, and that would probably be a physical change. In this wood example, or any other burning example, it's very hard to put what's resulted back into being wood. So that would be an example of a chemical change. Here are some examples of physical versus chemical changes. Physical changes are easily reversible. Usually no new things are being made, it's just a different shape or size of the original physical thing. Often state changes like boiling, evaporation, condensation, sublimation. So ice melting from solid to liquid would be an example of physical change. For a chemical change, not easily reversible. New products are being formed with new names. The reactants are used up, so after the fire, there is no wood left. Maybe heat, light, or sound are being made. So here are 5 signs of a chemical change. If you have one of these 5 signs, there's a 99% chance that it's a chemical change. If you have 2 of these 5 signs of a chemical change, it's a 100% chance that a chemical change has occurred. So for example, if the object changes color, then more than likely not, it's going to be a chemical change. There are some examples where a color change can happen with a physical change, but they're very rare. If a precipitate forms, so this is not rain, this is a solid being formed by mixing 2 liquids. If a precipitate forms, that's precipitation, that's a chemical change. If the object's temperature changes just based on mixing or 2 things happening, then that's likely a chemical change. So for example, after the fireworks explode, their temperature increases, that would be a chemical change. If gas is produced, now this is not boiling. Boiling is totally different. Boiling is a physical change. If a gas is produced, That's a chemical change. So if, for example, this metal is placed into either water or acid and bubbles form, that would be a chemical change. And finally, if the characteristic properties change, like for example, a glow stick, light is given off, or if the odor of an object changes, that's likely a chemical change as well. Now, if you ever see a chemical formula that has a chemical change on it, it will look something like this. The reactants, the left side, and the products, the right side, will be different. On the left, we have hydrogen by itself and diatomic oxygen by itself. But on the right, the hydrogen and oxygen are put together. They are different in a different arrangement. That is a chemical change. So that is what a chemical change will look like in chemical formulas. The left and the right side will be different. Now, as far as chemical change goes, here's a few more examples. Burning a match, cooking food, rust forming, and digesting food. So once the food hits your stomach acid, it starts breaking down chemically and is no longer physical changes. Now, finally, chemical properties are things that you can only see or only test by using chemical changes. So for example, flammability. Testing the ability of something to catch fire can only be done using chemical changes. Reactivity, or the ability to react chemically with oxygen or water, can only be tested by actually reacting the substance with oxygen or water. So those are the most common chemical properties that you may see. There are a few others like toxicity, chemical bonds, and testing what oxygen state something is in. So there is chemical properties.